Oh, good morning. This is a very chilly Sunday morning. Thank you for joining me. And this week we are going to discuss something called destructuring. It's perfectly harmless. We're not going to break anything, hopefully. Well, we might break some code, but code is soft, so it's meant to be broken and fixed again. And yeah, so it's a really nice technique to help you like pull out values from arguments and data structures, and it can make your code a little bit nicer to write as well. So we're going to look at that and what it means and lots of examples. And there's also a Clojure, a 4Clojure exercise that we'll go through that will use destructuring for that as well. Let's see, let's share my screen. Share, if we go funny, present to everybody. There we go. Oh, it's me in reverse. There we go. So there is this. Oh, there's intro to destructuring 2. I wonder where intro to destructuring 1 is. I should have looked for that. Yeah. So this problem 173 in 4Clojure.com is an introduction to destructuring. Let's go and see where in. The first one, 73, 23. Oh, there we go, 52. Thank you, Google. Okay, so we'll look at both of these exercises, and we'll also do some exercises I've got in code as well. So those are the two. So what actually is destructuring? That's a good question. So there's lots of, if you do a Google of Clojure destructuring, there's lots of different guides, and there is actually a cheat sheet somewhere, I think, as well, a cheat sheet. So we'll have a look through that. So let's have a look at the first result, Clojure.org. So essentially it's a way to bind names to values that are inside a data structure, and be able to allow us to write more concise code and hopefully more readable code as well. And so there's the example here. We're defining this data structure. I'm going to make this page a little bit bigger. There we go. There we go. And I'm going to hide the little Google Hangouts thing. So there we go. Okay. So we've got this data structure here called myLine, and it's just defining some what I imagine are coordinates, starting coordinates of the line, so x and y coordinates, and end coordinates of the line. So if x is 5, for example, then the line would go from 5 to 10 points, and y would go from 10 to 15. So it's kind of a kind of diagonal line up, potentially. Well, it depends which way they go. And so we're actually using that with this let function. So you can use destruction with the let function, and also it's very common to use with like functions themselves as well. So when you're managing their arguments. So in this let, let's see, let's just pull this down into my editor. And I have Emacs somewhere, there we go. Do 4Clojure, okay, let's see. Paste that in, let's make this a little bit bigger so it's easier to read as well. So we've got myLine. Oh, let's start my REPL. There we go. Fortunately, I had a bit of a hardware failure with my battery this morning, so I've had to restart everything. I actually had to disconnect my battery and reconnect it again, but luckily Lenovo laptops are very easy to get into and fix, so that's quite nice. So where do we get to? There we go. So I've got an expression here where I'm just defining a name called myline. Evaluate that, so that's now in the namespace. If we can now use that, so I can now do, if I wanted to do my line, auto completes as well, and then I can get a value for that as well. So it will, oops. So that's just a handy name to represent that data structure being a vector that contains two elements, and each of those elements are a vector themselves, and each vector contains two integer values. So what are we doing here with let? So we're defining, we're basically pulling out the first value from my line, and the first value is going to be vector, and then the second value is going to be this vector. So with the let, we can, once we've defined this local name, as soon as we've defined it, we can then also use it as well. So we're defining P1, P2, and then we can actually use P1 here and P1 and P2 and P2 here as well. So what we're doing here is this is a very specific way of pulling out each of the vectors for P1, P2, and in each vector we've got the first value and the second value, and the first value and the second value. If well, rather than print line, let's change this to string, and then we can see that we don't need to go into the use str. And so if we evaluate this, let's do that again. Boom. Oops. So it's printing out line from 510 to 1020. So it's using these values of x1, y1, x2, y2, and y2 is the second value from the second line, which is 20, which is nice. So I wonder if I can keep this instruments. I'm just using the cider debugger, just comma db, and this will show me the values of the intermittent, so the local values as we go through, walk through each of these lines. So you can see my line is the whole data structure, and we want to get the first from that, which is 510. We want, and second, we're doing the same thing there, except we're getting the second value, which will be 1020. And then we got 510, which is the first value from the first of my line. And the 5 is the x1. And the second value for that is going to be 10. And then the first value from this is going to be 10. And so on. This is going to be 20. This gives us a way to, very simple, very descriptive way of pulling out all the values from this data structure, from this myline data structure, and then we can, oops, I didn't want to do that. And then we can use that inside some behavior here that we've got here as well. That's the result. Oh, hello, oh, people are online. Oh yes, good morning everybody. Yeah, glad you made the slightly earlier start. Yeah, so this is pretty standard stuff. This is pretty easy stuff. Hopefully things that you would learn fairly quickly to assign values. So this let is kind of doing a local version of this def function. So def, I can use my line anywhere within inside this namespace. Doesn't matter where I call my line from. So I'm using my line inside the let. But the values I'm using inside the let, so P1, P2, X1, and so on and so on, I can only use those inside the let bracket. So, I'm defining a let, and if I go to the end of the let is there. And after that point, then all of those local values, P1, X1, Y1, etc., they're no longer available to me. So if I did X1 here, but did X1 here, I shouldn't be able to evaluate that. My linter is saying that there's an error there, and I can't actually evaluate that. It doesn't exist, so the symbol is not there. I think it's a useful kind of distinction to understand when to use def and when to use line. So def, I'd always use globally in an expression all by itself. I wouldn't put a def inside here. That doesn't feel right. I'm not sure if it works either. So if you want to have local values, so if this was some kind of function we'd defined. And then we could include the let inside there. Brackets as well, square brackets. That's not right. So we would use the let inside a function or inside some expression, whereas we use the def all by itself as well. Cool. Yes, interesting comment about the debugging. Debugging is like really nice. The simple debugger inside Cider, it actually does an awful lot of stuff you want. And there's also an inspector as well, so you can actually inspect through data structures and see what their values are, especially if they've been dynamically built up as well. So I'm just using the comma debug B for Cider debug definite at point. Alrighty, so that's so we're not actually doing destructuring here. We're just basically doing with the let. We're just doing assignments, local assignments. What are we going to do here? Oh no. What was that? My brain's forgotten how to do things in the morning, on Saturday morning. Oh, there we go. Boom. So I'll put that back, that let back. You can use a let by itself, but typically in your program, you're going to be using a let inside another expression, usually a function definition. So let's go back to here. So yeah, as it says here, it's perfectly valid code, but it's quite verbose, and it doesn't allow us to kind of do anything particularly interesting. So here, where we've got a small refinement in what we're doing. So just copy this. So we've got the same, more or less the same thing, except this time, instead of my line just going to a single value, and we're doing it, because we're kind of doing it twice here, we're kind of using destructuring. So we're actually saying, what is the shape of the value we actually want to get out of this data structure? So we've got my line, which is our data. What do we actually want to, what's the information we want to get from that look like? What's the structure of it? And in this case, we're saying, well, we actually want 2 elements from it. We actually want one element 1 and element 2. So P1 and P2, like position 1, position 2, they're going to represent that. So let's use the debugger again, just to show you what that is. Hopefully you can have a good guess about what it's looking like. So that's our my line value. It's just the same. We haven't changed it. But if we then go and look at P1, we can see P1 is 5 and 10. So it's like the first element from the myline vector. And P2 is the 10, 20. So instead of pulling out the individual values, we pulled out the first and second vector within inside myline. And then X and 1, no X1 and X2 are, oops, let's do that. Yeah, so X1 and X1, Y1, this is where we pull out the specific value. So P1 is just a single vector of 5 and 10. So then the shape that we want is this X1 is going to be the first integer value, and Y1 is going to be the second integer value. and the same for x2 and y2 as well. So we get the same result here, and oops. What did it do? Oh, okay. Oh, print line. Let's change print line to string again. As you see, print line is doing a nil, which is correct, but then I'd have to go and see. I'd have to go and look in the REPL to go and see the actual results of the print line statement. Okay, so we've done a little bit of destructuring. You can already see that it's a little bit easier to work with. We refined down exactly what we're actually looking for, but it's still a little bit wordy. We can probably make it a little bit simpler than that. Let's go and have a look, see what the website did. Yeah, we're basing on kind of sequential order. And let's see, what have they done? Okay. Oh, is that the end of that example? It is. Let's just explain what it is here. So it could be that. And here's where I haven't done this earlier, so I'll break. So rather from my line, instead of P1, P2, if we did, let's see if this works. We get another bracket and did X1, Y1, and then spacing. I don't think you need the space, but there we go. And then X2, X2, Y2. And then in theory, I don't need these. Yes, let's see if that works. Fingers crossed. Working this morning. Let's see. It works. There we go. Cool. Excellent. So rather than doing this all on like lots of different lines, you can just really say what pattern. We can just basically define the exact pattern of what we want, how we want it, and then these local values, these local names that we're creating for the values, then we can just use them inside our function as we're doing here as well. So this is maybe the first time you see destructuring, it might be a little weird, but once you get familiar with it, then you can say, well, this is just the pattern we want to extract. So we're matching the values in my line with the local value, the structure of the values in my line with the local names that we want to create. So you can make this nice and simple. And once you get a little bit of experience there with Clojure, then it becomes kind of second nature to just be able to read these things through as well. And let's see. So did I do the right thing? Nope. So let's see, does it show us? So we see, and we can see the values that are coming through are the right values there as well. Boom. Okay, so that's the very basics of destructuring. Actually, just showing you like using a vector. We're basically destructuring. We're looking at the structure and decomposing that structure just by using parts of it. And we don't actually have to use all those elements as well. We can actually go in and say, oops, what are we doing here? And go in and change this around a little bit as well. So what if we just wanted the starting point, then we could just actually say we're not really interested in a particular value, and that way we could get rid of this. Boom. Oh, sorry, I want to go that way. Yes. There we go. One. Starts. Boom. Let's see. Oh, there we go. Cool. Oh, I need a bracket at the end, but there we go. But you get the idea. You can very easily just use the values that you actually want from the argument you're passing in. Oops. Oh. Hey, there we go. Okay, so that's that's specifically destructuring with vectors. So vector is like is a very nice, simple data structure to work with, but we can do it with other things as well. So here, so here we've got a a vector of 1, 2, 3, and we're pulling out the x, y, z or x, y, z values from my vector, and then just printing that out on 1, 2, 3. That's quite simple. And that's working the same for a list and also for a string as well. Yeah, so we've got string ABC, and it's just pulling out the individual characters there. And this in this specific expression, we're just getting the type of those values, which is characters. So each of those are character Javalang characters values as well. So you can work. So you can work with. Excuse me. So you can work with vectors, lists, strings very easily. It's all just the same. It's just basically the position, the structure of the values inside the data structure that you're referring to. And yeah, so if you're getting values out that are not the same, so here we've got a small list, but we want to pull out a lot more numbers from that. It's still going to work, but when there's no values, it's Clojure is just going to return a nil value for you. So rather than failing, which some things might do because of types, then this is dynamically just saying, okay, if there's no value there, I'll just return nil. So although that might give some strange results, it's not going to break. It's not going to break your code. Your code isn't going to crash, and so it's quite easy to put some defensive programming around that as well. And likewise, if you've got a very long list of values or a long vector of values, you can just get the first 3, and you would just discard the rest. So you might only want like the first thing from a list. And you can just destructure that very, very easily. So you've got a lot of control over what you're going to create local names for. And you can access, is it going to, yeah. And you could actually just access specific names, so specific values as you want to. So here we've got item 1, 2, 3, 4, 5, 6 from names. Yep. Yeah, I don't think that's telling us anything interesting. Oh, this is more interesting actually. Yeah, so here let's copy this and have a play with it. So let's take our names from here. Boom, boom, boom. Let's put them into at the top of the page. Beep. We've got our names. Let's evaluate that just so it's in the REPL. There we go. Evaluate that. Oh, I didn't evaluate that. Right, there we go. It's in the REPL. So we've got names. Yeah, we've got names. Names. And that will work. That will return us a vector of strings. We can play around with that now as well. And in the example, what were they doing? So yeah, here we're getting individual values, but we might not want them all. We might not care about them all equally. So in this case, we're grabbing just the first name. So let's look at that. So we got name. I'm going to call that name one or person one. Person one, just so I know what we're doing. And then we got names, and then we're going to one. There we go. Oop, come on. So what are we doing here? Remaining people. I like quite descriptive names myself. So we've still got a let function, so we're assigning local names to values. And so we've got our let definition, and inside here we're defining the structures. So the structure of names is a vector. So this is this vector here, and the person one is representing the first element of that vector, and the first element of that vector is Michael. So that value of Michael should be now bound to person one. And then we've got this ampersand, which means basically everything else. So we're getting the first value from names, and then everything else. So Amber, Aaron, Nick, Earl, and Joe, that goes into another local name called remaining people. So it's all the other people that we haven't put into person one, basically. And we're pulling them from names, as we've seen before. So if we print line person one, then it's going to print out person. It's going to print out. I'm going to change that a little bit, actually. Change it to let's do the first one is this is a queue of people, and then we can use person one. Person one, there we go. And if we evaluate that, the first person in person one is Michael. Easy peasy. And then we can possibly do let's do this. The people queue. And then that would be remaining people. There we go. I know I spelled queuing wrong, but never mind. So if I evaluate that, then you can see here, actually, yes, because we're using because remaining people is actually a vector of those names, it's actually putting some funny stuff around each of the names here. So we would have to, let's see, we'd have to apply string over each of those to make sure that they're correct. So let's just try that. Apply str over. Slip that in. String. Very many people. I'll evaluate this again. There we go. Oh, yes, I might need to inject a space in between these people's names, but there we go. It looks a little bit better. I think we can, is it? Let me have a look. So let's see. So let's just have an aside of what string's actually doing. We've got string. Oops. we do that, what do we get? If we go there, we get some funny characters in the result if we just put a string over that. We apply, let's leave that there actually. If we apply string over this, then we get slightly neater kind of output. Oops. Although we don't get any spaces, and I think it's if we use Clojure.string string, and then is it interpose? Maybe interpose is just interpose. Interpose. Space in between names, actually, isn't it? Yes, I can just use names. There we go. The vector in there again. There we go. So if we do string with that, join them all together. Oops. And we get boom, boom, boom. Boom. Oh, lazy sequence. No. Oops. Okay. Oh, is it apply string? Maybe. Just take it when you get a lazy sequence. There we go. Well, that was a bit of an interesting diversion. I hope you managed to follow that one. So essentially, what we're doing is, so if we go back to destructuring for a moment, so here we got person one. So we're doing something specific with person one, and then we're doing something later with the remaining people. So we can separate out like the most valuable and the most important values, and kind of just group up everything else that we don't necessarily want to deal with. So if we put in that, I'm sure there's probably a simpler way to do that, but Sunday morning coding is not 100%. Let's see, let's do that back into there, boom, boom, boom. I'll push all this code up to onto Git at some point. So if I change that to boom, boom, boom. There we go. And let's kill that. There we go. That should work, hopefully. Yep. So the first person in the queue is Michael. The rest of the people in the queue are Michael, Amber. I suppose if I wanted to be correct, I'd do that. There we go. Awesome. So I can process the values differently depending on how I'm referencing them. So I'm using remaining. Oh, actually, I'm not doing that right, am I? That's not right. No, not right. Did anybody spot the bug? There we go. I should be using remaining people, not names. There we go. That's better. Because I've only got Michael twice, which I don't really want. But there we go. So that's destructuring for pretty much everything except maps and sets. So let's have a look, see if there's anything else interesting. Oh yes, and I've already mentioned you can ignore certain things, and these could be anywhere. So you can put these underscores, just like say, I just want to ignore the value, but it's keeping the structure. So this is item 1, this is item 2, but we don't care about it. It's item 3, item 4, but we don't care about it. So we're just using the underscore. 9 and 5. And if we just wanted item 1, then we wouldn't need any of this. But because we want item 3, if we didn't have the underscore, then item 3 would actually pull out the second value rather than the third value from names. So we have to have like a placeholder that we're not actually using. And you can do this with let even when you're not destructuring as well. You can use the underscore as a kind of a placeholder as meaning that I actually don't really care about this value at all. I can just ignore it. And it's quite a common convention in Clojure and in other languages as well. And so see, oh yes, this is quite useful as well. So if we want to refer to the first value, but then still also want to refer to all of the values, we can use this :as directive, basically saying that this represent the whole value of names, and so we can get specific values out, but we can also still keep all the names as well. Let's use this example. Actually, this be more nicer as well. Could be. So we got our def numbers here. Boom, boom. And so we've got numbers. Numbers should work now. Numbers should be there. We go. Numbers, and if we're going to use numbers, what are we doing here? We're getting the first number, so x will be 1. Yes, it will. Yes, x will be 1. And then remaining will be 2, 3, 4, 5, and then as all will be 1, 2, 3, 4, 5 as a vector. So this will be a vector of 1, 2, 3, 4, 5. This is a vector of 2, 3, 4, 5, and this is just an integer value of 1. Let's see what this one looks like. Oh, apply string. PRN is just like print line essentially. I think it's a slightly nicer form. Yeah. So the first, so that it's printing out remaining, which is a list of 2, 3, 4, 5, and all is 1, 2, 3, 4, 5. And so actually the fact that one's in a list and one's in a vector doesn't really mean anything. You'll be using them just as values, so it doesn't actually change how they're represented as a data structure. But yeah, so we can pull out values individually. We can pull out the rest of the values we don't want and group them into a collection, and we can also do all of the numbers as another kind of local value as well. So we can split this up. We can split up numbers in a whole different range of ways. So we can get x and y, and obviously we get slightly different results. 3, 4, 5 instead of 2, 3, 4, 5, but we're still getting all of the numbers as well. And if we did x and y, then we get 1 and 2 there as well. So you can split these up a whole bunch of different ways very, very easily. What we did, this should work as well, I think. Z. There we go. So now we've only got 4, 5 as the remaining because we've got x, y, and z, but we don't care about the value for y. So we're dropping that just by using the underscore, and we've got the remaining, which is still 1, 2, 3, 4, 5. So there's quite a few different ways to play around and experiment with those as well. Oops, that's not what I wanted. Any questions from the audience? Nope, not yet. And there we go. There's an example using string, some more examples using more strings. Yeah, so any kind of combination there. And oh yes, we already did this. Oh, I got ahead of them. So yeah, here we're doing a nested, yeah, as we saw in the first example, we're doing a nested structure. So we have to kind of ignore the first square bracket because that's the let itself. And then inside the let, we're defining this structure, which actually is the same as these myline structure as well. So if you put them next to each other, you can very easily see that x5 is going to be x1, 10 is going to be y1, and so on and so on. Yeah, and so you can do that a whole different levels as well. So and you can also use the as inside that as well. So group 1, group 2. Yeah. So here, the group 1 is going to be this first vector, and the group 2 is going to be the second vector. So that gives you again another way to do that. So that's pretty much it for the positioning side of things. So like with vectors and lists and strings, you're basically just representing the position of where something is in the data structure, and therefore you can pull it out. The other part of destructuring is when you're working with maps. So vectors is quite common data structure to use, and so is a map. A map gives you these key value pairs, so you can actually, sometimes you can be a little bit more descriptive about the data you're dealing with. So for example, here, rather than having a vector of Superco, Philadelphia, the world leader in plastic tableware, we've got these key value pairs. So the name is Superco, the location is Philadelphia, and the description is what they do. So that using a map again is a nice, clear way to describe the data while you're actually defining it as well. And so we can, with the maps, we can then, before we get into destructuring, we can go back to show you just what it's like. So this is section associative struct. So let's paste that in. And anyway, it's the client. This is our client. It's just a map. So it's a map of 3 key value pairs. And we can use the values from this map by getting the name from the client. So the map we've called client here. So we can use client and just pull out the name. So this if you don't remember, we did cover this previously. So you can call, if you want to get a value out of a map, you can do get from the map. Oops, I can't spell. Still can't spell. There we go. From the map, a key, the value that a particular key points to. So if we want the name, the value that the key name points to, then that's how we'd write that. And if we evaluate this, then we go. And the same for location and description. But there's also a short form of this. If we do, we can use the keyword to be able to pull out from the client's map the value. So what is the value of name inside the client map? Oh, there we go. So these two things are exactly the same. So here we're explicitly calling the get function with 2 arguments, the argument being map and the keyword you want to get the value for. And here we can just actually call the keyword as a function, giving it the map as an argument. And they will both return the same results. And just for completeness, you can also use the map itself. Oops. The map is called client. And you can give the map a keyword and it will pull out the keyword for you, or the value that the keyword points to. And so if we do that, we get the same value as well. So these are just different ways of writing it, but essentially we're just getting from the map the value of this keyword. And so the reason I've talked about this is because they've used the short form here. So this is the same as get from the client the name or name client or client name. But essentially it's getting superco and giving it to this local name variable. Local, it's not variable, local name. And this is a local location name. It's doing the same, and the same for description. And if we do that, boom, boom, boom. Oops. So we get Superco Philadelphia, the world leader in plastic tableware, which I assume is awesome. So this is just a simple let function. We're not using anything particularly interesting in here. We're not using destructuring yet. So let's see. Oh, how are we doing? Okay. So can we do any better than this, as we did with the positioning destructuring? So again, we're putting in, so in the let, we're now using a map to kind of show what it is we want to pull out from there. So we're actually including a map that looks like the map that that is client. So if we look at client again, these two maps pretty much are the same, except we're just creating a local name here for the value that name is going to return, and creating a local name here for the value that location is going to return, and same with description as well. So let's grab that. This is doing the same as this, except we're starting to do some basic destructuring. And again, it doesn't really save a huge amount in this version yet, but we can be explicit. And I guess we don't actually have to use the same name. If we wanted to have a different name than the value we're pulling out, we could do that as well. Let's just change that. Oops, no. There we go. Yeah, it's doing this exactly the same thing. It's slightly smaller. And again, it's using, rather than positioning, it's using these keywords. So we could actually change the position of these around, and it won't actually make any difference. Hide it off a bit. There we go. Yep, there we go. So that is kind of one slight advantage with destructuring. With maps, you don't have to worry about where the positions are. Oops, oh, sorry, I just did that wrong. There we go. There we go. So it still works correctly. So it doesn't matter if the location is the first place in the map or the last place or anywhere, because it's only pulling out the values based on the keys. So these keys could be in any kind of order inside the map, but we don't really need to worry about that. As long as we actually know the names of the keys, then we can do this very, very easily. Okay, let's see what else. So, oops. Can we do any better than that? Oh yes, so this is just doing, yeah, so if you bind a key that doesn't exist, it's just, again, just going to return nil, so it's fairly safe. Obviously, it'll give you unexpected results, but yeah, unless you're doing something with the nil to make it work, to make it crash, then it's going to be perfectly fine. And here we're actually using this OR directive to say, well, if we can't find category, then we'll actually just return a default value. So in this case, we're just returning the string category not found. So again, it's very easy to put something in there that will kind of make sure that everything goes okay with your code. There we go. And so what are we doing? Oh, and the same thing we're using as well in here. So we can grab everything from the map. So this will be a map called all As you can see here, this is the map it's producing as well. So this is so it's actually just printing out the whole map because this is referred to by this all local name. And we can combine them as well as we've done before. So yeah, so we've got A bound to A, X bound to keyword X, and then or if X is not found, and then as everything else. So my map is now called all. And you can see here, so I got A from all, I got capital A, which is that value here, from all, and all is the map. So, well, we're still kind of like specifying kind of the names and the keywords. So it's a little bit verbose. So there is this directory called keys, which we can basically say from the keys, I want to create these local names, which are in the keys themselves. So if we grab this, so this is a really short form. Again, might look a bit strange the first time you see it. It's not too difficult to get into. So here, yeah, might as well just evaluate this. Let's just change that. So that's still producing exactly the same thing because there are name, location, and description inside the map. It's just going to hunt off the keys and then automatically bind the values for each of the keys it finds to the matching names in location and stuff like that. Let's see. But if you put in a name that's not a key in the map, then you're going to get an error in this case. So it can't find, in this case, it can't find location in there because there's no key called location 1, so it can't find it. So it's you have to kind of be exacting in the naming of that. And then what? Oh, and you can do the same thing with the values as well. What's this doing? Oh yes, first name, last name, string keys. So this is getting the strings of something. So the keys, so it's actually value for the keywords, but also strings and symbols for strings and symbol keys as well. Oh, right, okay, yes. So if you're not using keywords, you don't have to have, here we're just using a string as a key, but it's not a keyword, which is something slightly different. So key can be anything. It can be a string. It can be a function even, because that's returning a value. It can be a number. It can be a whole bunch of things that are legal kind of values inside Clojure. So in this case, the map is defined as a string as the key, and Joe as the value. And same thing for last name is the key, and Smith is the value. And so rather than using this keys directive, we have to use strings, and that will match on like the strings. So it'll match the first name. So this first name here will match the first name string that represents the key in the map. And you can use symbols as well. And because we don't want to evaluate the symbol, we just want to use the name of the symbol. We have to put this little quote at the start of the symbol, so that we say we'll just use the name of that symbol and not the value that it points to. So first name, if you did let's see, so if we did first name and then why did I do that? Yep. And so if I wanted to, if I use, if I evaluate John, sorry, if I evaluate first name, then I'm going to get John, but if I quote it, then I'm going to get his first name. So this allows me to use the name of the symbol, the name that I've defined here, rather than the value it's pointing to. And oops, and this is what they're doing here as well. You can use these symbols as keys as well, although most of the time it's pretty much you would use a keyword for your map, because it's usually a lot nicer to work with. And then so nested. So here we've got the nested thing. So if we've got like a game state here, we've got a game. So we got each of the players in the game, and each player has like what class of player they are. So they're a knight, wizard, and so on. And each player's got a weapon and a score. And you can use, because we've got our top level map and then our second level map inside there, we're using two curly brackets here to be able to get the keys from these nested maps, because we actually want to pull out class and weapon for Joe, and that allows us to traverse the right values inside the map as well. So here we got Sprinting Joe is a ranger, because it's pulling out class from this nested data structure here, and this nested map, and he's wielding a weapon, so he's doing the same thing with weapon as well. And I think there's about those keywords arguments. Oh yeah, and then we can do the same thing for so far we've done the keys, but I think you can also do the vowels as well. I don't know if there's an example for that. Okay. And destructuring namespaces. Namespace keywords using keys. Okay. I'm going to skip that for now. I'll leave that for you to read through. Where to destructure. Yeah, pretty much where if you start to get a lot of these kind of like very simple first, second, last kind of things, then it's actually just nicer to do destructuring. So if you compare these two pieces of code together, then once you get used to it, then destructuring is actually a much cleaner way to do that. And it makes it really nice and simple to do it, especially if you actually didn't want like the Y. You can again, you just do you do X_Z. It makes it very clear which values you're just actually working with. And what we got here, and just some more examples of where you would actually use it as well. There we go. Let's print macros. No macros. Okay. Macros is another thing in itself, so let's skip that for now. So there was 2 exercises, and I'm just going to wrap up the broadcast with just doing these 2 exercises. Oops, there's the answer. There we go. Hope you didn't see that one. Let's make this a little bigger. Control. So this is an introduction to destructuring. So this is number 52. Let's see. So there's a let bindings and function parameters lists support destructuring. So we want to see what's equal to, how do we get the value from the value of 2 and 4 in a vector from this expression here. So we've got our let, and we've got a vector that contains all our values here. So we want to be able to pull out the value of 2 and 4 from this structure. So we're pulling out all the values here. So we're pulling out A, B, C, D, and E. So which of those values represents? So A is going to be 0, B, C, D, and E. So we want C and E. So we do C and E, and then hopefully with a bit of luck, that should work. There we go. I think in this case, there's probably not much else we can see in the solutions, but let's just go and have a look. Pretty sure there's nothing else here. It's pretty much C and E all the way down. There we go. Yeah. Yep, so that's not particularly exciting, but that's it gives you a simple test that we can actually use this in a bit of code as well. So we've got that solution, and then there was 173, which is again, this is an easy one using destructuring. So sequential destructuring allows you to bind symbols to parts of sequential things, vectors, lists, maps, sequences, etc. Complete the bindings so that all let parts evaluate to 3. So all of these lets expressions, we need to get a value of 3 out of them, so they all equal 3. So we should have, when we evaluate these expressions, then each of those should become 3, and then we'd get equals 3, 3, 3, 3, which is true. Let's copy this into Emacs, Spacemacs. But I think I already started doing this. There we go. I did. Let's see. Not sure what I did there. Oh, okay. So that's no. Oh, this is me just playing around with the examples. Yes, there we go. So we got range 3. Okay, in fact, yes, this will work. There we go. 3. There we go. Yeah, so we're just putting this. So if we're pulling out function and collection, so here we're pulling out the plus as a function. Oh, I can do it here actually. Can I? We've got the plus as a function and the collection, which is range 3. If you don't remember what range does, let's just check this. Range 3 will generate a series of values up to the but not including the value you give as an argument to range. So we're doing 0 to 1 to 3. You can also specify a starting value as well. So you can do 1, and you can also do a step value, I think. So if you did 1, 2, 3, you get like a 1, 3, yeah, 1, 2, 3. You get a different result. 1, because then it stops at 3, but you're already skipping from. You're starting at 1. You're going to skip 2, so you're going to do the 3, but 3 is the last one, so that's not going to work. So if you did 4, you get 1, 2. Yeah. No, you wouldn't. What's it doing? Oh, yeah. Oh, is that? I get that the wrong way around. What I've done. Yeah, I got it the wrong way around. There we go. There we go. So we're starting at 1, we're ending at 8, and we're skipping 2, so we're doing 1, 3, 5, 7. That's how range works, but we're using it to just generate 1, 2, 0, 1, 2. If we add these numbers up, then we can see we actually get 3. So we're actually, if we just apply the function to this collection, then we're actually going to get 0 plus 1 plus 2. So we do apply plus, where's plus come? Plus. And then this is a of range 3. Then we get 3. So basically just adding up 0 plus 1 plus 2 equals 3. So that's why we get that value there. We get that result there. So here we're putting in, in here we're putting in like a placeholder for a function and a placeholder for a collection. and so it's going to grab this this plus as a function and this range 3 expression as the result of that is going to be the collection, and then it's applying those together. So we should, in theory, just need to get same in all of them. So here we're getting the same thing. This is a nested expression from B. So B is a vector of vectors. Well, a vector where the first thing is a vector. So we want to grab that value out of there, and we want to get the value, and then we can just do the collection with plus 1 and 2, which is 3. And we're doing the same thing here with inc and 2. So if inc 2 is increment 2, then we get 3 out of there as well. So we just return the collection. So they all work the same thing. So basically, we just have to put function and collection in there. The same thing for that. So if we do here, to get a low golf score, we've just used x and y, but essentially we put a function usually just function collection. So we get the function from here, so it's plus, and we get the collection plus, and then we put the function collection in here, goes in here to get these values. So putting them here gets the plus and the 0 to 2, and then we put function and collection in here, so it applies the function to the collection and gets the result. So if we do this as our answer, we should have green, 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 green. There we go. And if we see the solutions, we'll just see people have just used X and Y or A and B or A and C just to get a lower golf score. Oh, somebody used plus specifically. Okay, that's hard-coded plus. You didn't really need to do that. Op, I guess they've used that as operation. And yes, so there we go. Oops. Where do we go? Oh, cool. Any questions? I don't think there's any questions. I'm going to leave it there for now. And thank you very much for listening. And I hope you enjoyed destructuring. There is lots of interesting stuff out there. Was there a cheat sheet somewhere? Right, there we go. Somebody else has done some cheat sheets. There's lots of kind of examples. If you Google destructuring in there, there's lots of examples of how to do things. I quite like the, what was it? Yeah, there's a nice guide here from Bruno Bonacci, if I pronounced that correctly. Is one of the local London Clojurians. And there's Jay Fields destructuring as well, which I think is quite nice. I'll put these as links in the at the bottom of the broadcast. Okay, thank you very much, and I'm glad you liked it, Connie. Thank you very much, and thank you, Ali, for joining in. And I'll figure out what we're going to do next week. If you've got any suggestions, please let me know, and we can see what we can get done. Next week is our 13th Clojure study group, so hopefully nothing breaks too badly. Thank you very much, and goodbye.